In this video, we're going to create a new project file. Now, the word project and model are synonymous in this context. So when we look here on the home screen, you're going to see that it says models over here on the left, and it says models here under recent files. In both cases, model files are the same as project files. Now, in Windows Explorer, they're going to have an RVT extension. So the Revit file itself would have this RVT extension, and that's how you know it's a project file. And over here, it's simply referred to as a model. And to create one, I would click this new button right here, and that will open up the new project window. So hopefully that's not confusing, that both model and project really mean the same thing in this context. Okay, so once we're here in this dialog, the most important setting in here is choosing a template file. Now, what you see on this list might vary. This is dependent on what you've installed, what region you're in, what you configured in options. So let's not get too hung up on what is shown here in the list. What we're going to do instead is we're going to use this browse button. So I'm going to click on that, and I've got the US Imperial installation of Revit. So it takes me to this English Imperial folder here, and you can see that that folder contains a variety of template files. Now, as I mentioned, project files have an RVT extension, but notice that template files have a different extension, RTE. So when you create a file initially, it's going to be based on an RTE file, but then when you save that project, it becomes an RVT file. So the template is just the starting point for a project, and it can configure any number of things, all the different settings. It can be Office standards, anything that you want to include in a template file. And the goal is, again, to just give a consistent starting point from one project to the next. And just looking at some of the names that you see in here, you can see that there's a lot of different ways you could approach that starting point. So there's one here for plumbing and mechanical. There's another for commercial. There's one down here for residential. So there's a lot of different possibilities. Now, the one that we're going to use in the projects in this course is called Default Multidiscipline. And when you select it, you'll see this little 3D icon over here on the preview window on the right-hand side. So that's how you'll know that you've gotten the correct thing. Now, in this course, you can work in either imperial units or metric units. So this one, Default Multidiscipline, is the imperial version of this template. If I go up one folder, that takes me to the templates folder with a number of different languages. If we go into the English folder, you're going to see all of the same templates here as metric versions. And if you would prefer to work in metric units, this is the one that you want to choose. Default Multidiscipline Metric. Notice it's got the same preview icon over here on the right. So on screen, I'm going to use the imperial version, but as I said, you are welcome to use the metric version if you prefer, and I'll refer to both units along the way. So I'm going to open that, and then I'm going to click OK here to create a new project based on that template. So there's some visual things that we see right here in the middle of the screen. So you've got these indicators around the four sides. These are elevation markers. Now, if I zoom in on some of these, you'll notice that those elevation markers already have sheet references in them. So this one at the top says that it's 1 on sheet A201, and this one says that it's 1 on sheet A203. Now, those sheets are already included over here on the project browser. So if I scroll down and locate the Sheets branch, so here's sheet A201 and here's sheet A203, and you can see there's 2 additional elevation sheets here as well. In addition to the elevation markers that you see, there's this section marker running across the middle of the screen. Now this one, if I zoom in, is not yet on a sheet. So notice it does not have a sheet reference filled in, and it's actually grayed out in this dashed line, indicating that it is a working view or a temporary view that's not really intended for a sheet. Now we have these 2 dashed lines in the middle of the screen. Those are really just there for convenience, marking the center point of the view here, but they're also showing us where the origin point of this model is. Out here, we have this item, which is referred to as a scope box. Now, what a scope box does is it controls the size and scale of either a view or a datum element. We're going to talk about datum elements in the next few videos, levels and grids. So we'll discuss those more in the future. But the view itself here is being controlled by another one of these scope boxes. Now, the best way for me to show you that is to come up here to the quick access toolbar and click on this default 3D view icon at the top of the screen. So that's going to open up a 3D view. And here you can see that there's actually two of these green dash boxes. This inner one here is called grids and levels. And so that is meant to control the extent of the levels and any grids, which again, we're going to talk about shortly. But this one out here is labeled views overall. So here's how this works. If I were to select this scope box, you'll notice that it's got these series of grip controls on all of the different sides. If I were to drag one of those grips and resize the shape of that box, notice that if I go back to the floor plan, this floor plan has already recropped itself to match the size and shape of that scope box. Furthermore, if we were to open up one of these elevations, which I'm going to do by double clicking this little triangle on the south elevation, notice that it also has been resized accordingly. So the purpose of a scope box is to give you one place to go to be able to modify the extents of lots of views all at once. And that just helps with a consistent sheet layout. So when you consider all of these sheets that I have down here at the bottom, if we needed to resize the viewport of one of them, there's a pretty good chance we might want to resize the viewport on several of them. This is a convenient way to do that, and it's already built right into this template. Now, I don't want to keep that change, so I'm going to come up here and click the undo button in order to resize that scope box back to its original configuration, and then I'm going to close the south elevation to return to the first floor plan. So those are just a few of the settings that are already here and configured in this template file. Now there's lots more. So I just want to point out that this was a multi-discipline template. So I've been focusing on architectural views because that's our focus here in this course. But if you scroll down, you'll notice that there are several other branches here: electrical, mechanical, plumbing, structural. So you can use this same template for any discipline as a starting point. Now, there's also some symbols here, a north arrow and a bar scale. So there's lots of different settings in this template, far too many for us to go through in exhaustive detail. But what I wanted you to see was just some of the things to be on the lookout for. Now, I promised you at the beginning that I would contrast this to a file created without a template. So if I come up here and highlight New from the File menu, slide over here to Project, and then open up the drop-down list here and choose None, I'm going to click OK. It's going to ask me what units I want to use. I'll do imperial. You can do metric as well. And notice I get a blank screen. I don't get really any views at all. I get just one floor plan, one ceiling plan. I don't get any sheets. There's no symbols. So none of that setup. There's no scope box. None of that setup that I just showed you that was in the template comes across if you don't use a template. So using template files is the easiest way for you to get a good starting point on a project that matches whatever office standard or configuration that you're after. So I'm going to close this one without saving it. And this is going to be our starting point moving forward for the files that we're going to be building in subsequent videos. Now, if your office has its own custom template, then you would certainly use that for projects that you do within the office. But for purposes of what we're going to do here together in the course, I recommend that you work with this template and the files that I'm providing to get the best experience, but you are certainly welcome to use your own template if you prefer. In the previous video, we created a new project from one of the provided Autodesk templates. In this video, what I'd like to do is start configuring this project with the settings that we need for the project that we actually want to create going forward. Now, I've actually opened up both the Imperial and the metric version of this project on my screen. You don't need to do that. You only need to work in whatever one of the two matches your unit preferences. I wanted you to see both on my screen, however, so that we can just see what the differences are between the two. And it is subtle. So going forward, it won't matter whether you're working in imperial or metric, because I will mention both units on screen. And what you're going to see here is that it's mainly the units that differ between these two. So the tab I have open right here is the imperial version of this file. So it's called Project Start. And what I'm generally going to do is name the metric files with an M prefix. So notice that this is the metric version of this file, and it says M_project start. And otherwise, it looks largely the same. The only real difference between these two files is the unit configuration and some of the content that's loaded. Now, we'll talk about the loaded content in future videos. So in this video, let me show you the units as a setting. So I'm going to go back to the imperial file, click over here to manage, and then to get to units, it's on the settings panel here, and there's a units button right there called project units. Now, what I want to do is just point out a few of the units that are set here. For length, as an example, this file is in feet and fractional inches, and it's rounding off to the nearest 32nd of an inch. Now, you could change that level of rounding if you prefer. You could suppress 0 feet when they occur, when you're only showing inches, and you could use digit grouping, which means that it would show 1,000 for 1,000 versus just 1,000 without the comma if you turn that off. Okay, so those are some of the settings there. I'm not going to change anything. I'm just going to cancel and accept those defaults. But let me just point out some of the other units that are in here. Notice that slope in the imperial file is in rise over 12 inches of run. Okay, let me cancel that. Notice that volume is in cubic feet. Notice that area is in square feet. Okay, so let me cancel out of here and let's contrast that to what we see in the metric file. So I'm going to go to metric, go to manage, click on project units. Here's the length setting. It's now in millimeters with no rounding. You could change from millimeters to centimeters to meters, in which case you might want to change the level of rounding. You can also suppress trailing zeros, and you can also enable digit grouping if you prefer. I'm going to cancel that without making any changes. Notice that this time slope is in degrees instead of rise over run. Notice that volume is in meters cubed and area is in meters squared. So otherwise, we're looking at essentially the same thing for both of these files. Now I'm going to click back to the imperial file, and the next thing I want to do is set the location of this file, and that's going to be in 2 steps. So in the first step, I'm going to set the location and the overall project information using a command here called project information. So when you click that, this is all just text-based information that pertains to the project as a whole. So there are some identity data fields up here at the top, which I'm going to skip over. And if I scroll down here to the bottom, you can see under other that there's a variety of additional fields. So just go ahead and fill this in with any information that you like. So I'm going to put in a project issue date and a status like design development. I'm going to give the client a name, put in a project name and a project number. Now I skipped over the project address, and the reason I did that is because this is a slightly different kind of field. Notice there's a small browse button here that opens up a larger window, and this is a multi-line text field. So you can press the enter key to go to a new line, and you can type in as many lines as required, which is pretty common for an address field. When you're done with all of that, you can click OK, and where does that information show up? Well, if you watched the previous video, you may recall that this template that we started with contained a number of pre-made sheets. So what I'm going to do is scroll down here now to the Sheets branch of the project browser. It's right there. And I'm going to open up one of the elevation sheets, A202. So we talked about this elevation sheet in the previous video, and what I want to do is zoom in on the title block down here in the lower right-hand corner. So I'm just going to put my mouse in that general area and roll it in to zoom in, and notice all those fields that we just typed in the project information are already filled in here on this title block. More importantly, if I open up a second sheet, I'll just go to A203. Notice that it also has the same information. So things like the name of the client, the name of the project, the date, the project number, these are global fields that will input all of the sheets. Now, if you discover an error here in the sheet, what you can do is actually click right on the sheet, then click again on that field. It's editable text, and you could modify it right here. So if I notice that the project number is in the wrong format, I can change it right here. That change will apply not only to this sheet, but it will also apply to this one, and it will also apply back here in the project information dialog. So it's not possible for those to get out of sync because it's the same information in all of those locations. So in a single location, you're basically editing all the sheets in the project. Now, there were some other fields on the sheet like who drew it and who checked it and the number itself. Those are all sheet by sheet. So some of the fields there are per sheet, where some of them, like the ones that we edited, are project-wide. Okay, now we just filled in project information, which included the project address, but I want to point out that the project address that we filled in is just text information. That doesn't actually change the location of the project. So if we were to do any kind of analysis like wind analysis or solar analysis or shadow studies, we would not be in the correct location in our project at the moment. So to set the actual physical location in the world, where you need to go is project location and then use the location button right here. That's going to open up this location and site dialog. Now, this is resizable. I've previously made mine a little bit larger. Notice you can just stretch here at the corner to resize it. So make it big enough that you can see the map. And then what you can do is use the project address field here to type in the location of this project. For this project, I'm using Boulder, Colorado. So I'm going to type that in and press enter. That's the same as clicking the search button here, and that will run a search, and it found two options, Boulder, Colorado or Boulder County. I'm going to click the first option, Boulder, Colorado, and it will take me to that location on the map. Now, this is probably sufficient if all I'm interested in is shadow studies or something like that. But if you want to get much more precise, you can take this push pin and you can drag it around, or you can type in a very specific address here, or even latitude and longitude, as you can see. So you can be as precise as need be for your circumstances, but just getting in the correct city is probably all that's required in most cases. But when you're done, just simply click OK to accept that change. So all that remains now is for us to save our changes. Now, rather than save over the existing file, I'm going to go to File, Save As, a project. I'm going to put it on my desktop, and I'll change the name and call it Headquarters. Now, there's lots of other settings that we could configure in the project, but that's enough to get us started and allow us to move on to the next step. In this video, I want to discuss two very important topics, saving and backups. So when you save your file, two things actually take place. Not only do you save and update the original file, but you're also creating backups. And I'd like to demonstrate how all of that works for you here. But the first thing and the most important thing is that you've got to be saving your file. So in order to take advantage of anything else that I'm going to discuss here in this video, saving is a must. And the most important thing that you need to know about Revit is it does not automatically save. So let me say that again. Revit does not automatically save. So if you don't personally click the save icon, type Control S, or go to File and choose Save, if you don't do one of those things, then your file is not saved. And should you crash, should the power go out, should something happen, you will be very unhappy because you will lose a lot of work. So it's very important that you understand that. So sometimes folks are surprised to hear that and they just assume that Revit would have an autosave. It does not. Okay. Well, what it has instead is a save reminder. Now, we've actually discussed the save reminder already in an earlier video when we talked about the options, but let me just remind you of where it is. If you go to the File menu, come down here to Options. At the top of the General tab of the Options dialog, under Notifications, you can see the Save Reminders. Now, as you can see, mine is currently set to 30 minutes. It is possible to choose a different increment down to 15 minutes or turn off the reminders. I don't recommend turning it off. And in fact, I think 30 minutes is correct for most users. So I'm not going to change anything there, and I will simply click OK. So what that actually means is if the amount of time that you've indicated in your save reminder expires, so in my case, 30 minutes, and you haven't saved, then the next time you perform a command, Revit will actually interrupt you with a dialog that will tell you that it's time to save. So let me try and demonstrate that by running a command, say the wall command, and notice that I get this save reminder. So it doesn't really matter what command I ran. So the fact that I ran a wall command wasn't at issue. The fact that more than 30 minutes has elapsed since the last time I saved is what the issue is. And I now get this save reminder here. So there are a few options available here. The absolute correct option is the first one, save the project. You really don't want to do the other two, and you certainly don't want to get in the habit of clicking cancel. Unfortunately, I see a lot of folks get in that habit because they're annoyed that they were trying to draw a wall and Revit interrupted them with this message telling them that they need to save first. So the idea is that, oh, I'll cancel that and I'll save on my own later. But the trouble is that we often forget. So the whole idea behind the save reminder is it's interrupting you when you run a command because it knows it's got your attention. So it's trying to get your attention and do what's in your best interest, which is to save the project. So please don't get in the habit of clicking cancel. Don't turn off the reminders. Don't change the reminders. What you want to do is click this first option here, save the project. When you do, Revit will remember what you asked it to do, in this case, drawing a wall, and then you can go ahead and continue that command. Now, I'm just going to draw a little segment of a wall right there. Doesn't really matter where. So that's the basic idea behind the save reminder. So, of course, the biggest benefit of clicking save the project is that you've actually updated your saved version of the file. And so if something should happen, you've got a saved copy. But there are some additional benefits to doing that as well. And there are also some additional options that I want you to see when saving your project in the first place. So let's talk about some of those. And to do so, let's do a save as. So what I want to do is go to the file menu here, choose save as, and then project. And I'm going to put this on my desktop and I'll keep the same name. But before I click save, I want to come over here to options. So let's talk about some of these options here. So saving your project is important just because, right? That's the only way you're going to preserve your work. If you save before that 30 minutes elapses, you won't ever see that save reminder. And so you can avoid being annoyed by the dialogue interrupting your work. But beyond the fact that you just want to avoid the annoying dialogue, you're saving the project, which is important. But what you see here is that under save options, there's this maximum 20 right here. Now, what does that mean? Well, that is actually a number of backup copies that are also being created when you save the project. So if you get in the habit of saving regularly, not only are you potentially avoiding the save reminder dialog, not only are you updating your work frequently, but you're also generating backup copies. Now, 20 might be a bit excessive, so I am going to reduce that quantity. 3 is a more common number, so I'm going to change that to 3 in this case, and then I will come down here and click OK. Then I'll click save. And so all I've done really is relocate my file to my desktop and change the number of backups to 3. Okay, what does that mean exactly? Well, let me demonstrate. What I'm going to do is I'm going to draw another wall right here. I'll cancel the wall command and I'm going to save again. Then I'm going to repeat that twice more. I'm going to draw a wall, click the modify tool to cancel, save again, and then one more time, modify tool, and let's save a third time. So I did 3 times because we asked for 3 backups. So now let's take a look at what we've actually done. Let's go to the file menu and let's choose open and then project. Let's go to our desktop if you're not already there. And what I want you to see is we now have our original file right here called headquarters. Notice that the preview over on the right shows a total of 4 walls. So if I move this out of the way, it matches what we see on screen there in the background. That is the latest version of this file. But notice that I have these 3 additional files here with numbered suffixes. So here is backup number 3. It only has 3 walls. Here's backup number 2. It only has 2 walls. And here's backup number 1. It has only one wall. Let me cancel this and let's draw one more wall, click modify, and let's save one more time. And now I'm going to go to File and choose Open. And now notice what happened. Backup 1 is no longer there. That's because we set our quantity to 3. So what 3 means is we're going to get up to 3 backups, but no more than that. And so it will always throw away the oldest version, number 1 in this case, and I'm left with 2, 3, and 4. And of course, the headquarters file represents the current state of the project. So if you get in the habit of saving often, not only are you keeping your file up to date and potentially avoiding the annoying save reminder dialog, but you are also getting several backup copies that you can fall back on should something occur where you need to restore an earlier version. Now, we set it to 3. You can set it to any quantity that meets your needs, but I think 3 is adequate in most cases. Now, I should point out that this backup mechanism that I'm discussing here is the way it works for standalone projects. If you're doing a Workshare enabled project, a team project, which we talked about in an earlier video, the method is going to be slightly different for backups. You would need to go to the Collaborate tab and use the Restore Backup tool here in order to access backups, and they would be stored in a folder instead of having the numbered suffixes. So I'm not going to go through that process here. I just wanted to point it out to you and make mention that it is a little bit different, but Workshare-enabled projects are backing up as well. They just do it in a slightly different way. So I hope that this exercise has shown you just how important it is to save regularly. The takeaway from this video is save often, but please, 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 when you see the save reminder, don't get in the habit of clicking cancel. Please get in the habit of clicking save the project. That is absolutely the right thing to do anytime you see that dialog. In this video, we're going to set up the basic levels for our project. It's one of the first tasks you typically do in any new project is establish the levels. And the levels simply represent the important vertical heights that are meaningful in your building. Now, the best way to set up levels is typically in an elevation or section view. In fact, it's not possible to work on levels in a floor plan because you have to be able to see the level. So I'll be able to demonstrate that by opening up a section to show you what I mean here. So there happens to be this section 1 running across my view here in this file, and I'm going to simply select that, right click, and choose Go to View. Alternatively, there's a sections working section branch here on the project browser. You could expand that, and there is section 1. You could just simply double click it there. So both methods would get you to the same place. So levels are one of 3 datum elements that we have available to us in Revit. They are levels, grids, and reference planes. And throughout the course, we'll talk about all 3, but we're starting here with levels. These 2 items right here are the levels, these dashed lines. Now, what you're actually seeing when you look at it in elevation or section is just the edge of that level, but really what it is a 3-dimensional plane. So if I were to go to the 3D view here, you can see the levels maybe a little bit more clearly and visualize conceptually what they are, because you'll notice that there's a plane here for the L1 and L2 levels, which are currently present in this file. Now I'm going to close my 3D view to go back to the section. So it is theoretically possible that you could manipulate your levels directly in 3D. Some people like to do it that way. I prefer to work here in the section. So that's what I'm doing. Okay, so the next thing I want to do is I'm going to ignore levels 1 and 2 for the moment, and I'm going to show you how you can create your own levels. So that's on the Architecture tab, and we're going to click the Level tool right here, or you can use the keyboard shortcut LL. So the way this works is it's like drawing a line. You're going to pick 2 points. Now, one of the things you need to understand about levels is they must be parallel to the ground. So you can see that very clearly if you click your first point and then start to move your mouse. Notice that it doesn't matter where I move vertically. It's only going to allow me to draw this out horizontally. Now, you could draw it to the left or to the right. That doesn't matter, but it's going to be a horizontal plane is what you're going to be creating there. So I'm just going to click that second point maybe right there. Okay, so that is my first level. So let's create a second level. And what I want to show you is if you move your mouse nearby one of the endpoints of the existing level, it will sense where it is. You can kind of get this little dashed extension line there. And if you click, that's going to keep those 2 points lined up with each other. And we can do that on both sides.
So notice that it kind of senses it over there as well. And it even locks those points together. Okay, so now to demonstrate that, let me cancel out of the command. I'll do that with the modify tool here. I'm going to put my mouse kind of right about here in the middle of these two levels, and I'm going to roll to zoom in a few clicks there. Okay, I'm rolling the wheel up to zoom in there. Next, I'm going to come back and select one of the levels. It doesn't matter which one. And you'll notice these little open circles at both ends of the line. Okay, so there's one right there, and there's another one right here. Okay, if you click and drag that little open circle, notice that it doesn't drag just the one that you're dragging. It drags also the ones that are locked to it. Now, in this case, it's just 2 levels, but if you had 20 levels all locked together, then they would all stretch together as one with that simple modification. If you didn't want that behavior for some reason, you could unlock it and drag them independently, but that's what it does by default. And by the way, if you've previously unlocked it and you drag it back again, when it snaps back, it will relock itself. So it's real easy to change your mind on that behavior. So that's the basics of creating a level and controlling how long it is. But now let's look a little bit more at some of the other settings that are available to the level. Notice that there are labels on the right-hand side. We have control over that. So I'm going to click on the level itself, and you'll notice that there are these little checkboxes floating off to the left and to the right. Now, the one here on the right is already checked, indicating that we have a label on this side. The one here on the left is not checked, but if I check it, then suddenly I will get a label on that side, and I could have annotation on both ends. Or I could uncheck this one, and now I have annotation only on the left, or I could change my mind. And in fact, you could turn off all the annotation if you wanted to, but rarely is that done. But I could change my mind and go back to annotation on the right. So it's up to you which side you want them on, but I'm going to leave both of mine set to the right there. Okay, that's a little bit about controlling the annotation. Now, the next thing I want to address is the color of that annotation. So notice that these two are black in color. However, if I hold the wheel of my mouse in and drag such that we can find the two existing levels that were already here in the file, L1 and L2, notice that their color is different. They are blue. So what does that mean? Well, it turns out that the blue color indicates that there are floor plans associated to those levels. And you can see that if you hover over the symbol, you'll get a tooltip that says, go to the view that corresponds to this level. Now, how exactly would you do that? You would just simply double click that blue symbol and it would open up that view. Notice that I'm now in the L2 architectural floor plan here, which is this view right here. Now, the other way that you can see that L3 and L4 don't have floor plans is notice that here under the floor plans branch, I only have the 2 floor plans. I don't have one for L3 and L4. So let's remedy that now. So I'm going to close the L2 architectural and then refocus my attention on just L3 and 4 here. And let's add some floor plans to those levels. So the way we do that is here on the View tab. There's a Plan Views dropdown. I'm going to open that up. There are a number of different floor plan types you can choose from. I'm going to choose floor plan in this case. And you can see L3 and L4 listed here. Now, it turns out that it's only showing L3 and L4 in this case because down here at the bottom, there's a checkbox that says do not duplicate existing views. And that's currently checked, which means that it is filtering out the views that already have floor plans. If you uncheck this, it would show all 4 of my levels. Now, I don't really want to add additional floor plans to L1 and L2, so I'm going to leave that checked. Click level 3, drag down to level 4, or you could just hold the Shift key or the Control key down to do that, and click OK. And that is going to create 2 floor plans. It actually opens up the last one, L4. We don't need to keep that open, so let's just close it. And then you can see right here, L3 and L4 have been created on the project browser. And of course, the colors of the symbols have now changed to that blue color to reflect that they now have floor plans. Now, the names you'll notice are a little different. When we created the floor plans for L3 and L4, it just used the same name as the level. But the other 2 floor plans have the architectural suffix at the end of their name. Well, it turns out that you can decide whether you want the names of your floor plans to match the names of the levels. It does that by default, but you don't have to accept that. So we can right-click one of these existing floor plan names here, L3, and I'm going to choose Rename. And then I don't actually want to name these the same as the other two because I want L3 and L4 to be roof plans. So this one is going to be low roof. And when I press enter, Revit will ask me if I would also like to rename the corresponding level. I'm going to answer yes here because I think it'll be useful to have that level name match that condition, the low roof floor plan. Now, it turns out you could do the level 4 the same way, or you could do it right here directly on the symbol. So if you click right on that L4 label, it makes it editable text, and we can call this one high roof. And it will ask the same question. I'll answer yes, and the floor plan will rename to match. Now, that is optional. Here, we've kept the names of the level and the floor plan connected to one another. So each time one of those gets renamed, it'll rename the other. But notice that here, the name of the level is just L2, but the name of the floor plan is L2 architectural. Once you've done that, then it's possible for the floor plans and the levels to have different names. So it really just depends on what your office standards call for or what the project needs dictate. So either one is perfectly fine. Now, I'm going to zoom out so that I can see all the levels, and I want to talk about the extents a little bit more. We've been dragging these manually, and that's fine, but I want to show you the behavior of L1 and L2 because they're a little bit different than what you were seeing there. If you click on them, the little open circle, first of all, is not at the end point like you'd expected. It's inset away from that a little bit, and if you try and drag it, nothing happens. And the reason for that is L2 and L1 are actually associated to something called a scope box. Now, what is a scope box? It's this thing right here, this dash box. Okay, and if I zoom out a little bit, you can see that it is exactly what it says it is. It's a box, and in fact, if we go to 3D, it is a three-dimensional box that has grip controls on all 6 sides. If you were to drag those grips, it will affect the extents of anything attached to it, which in this case is L1 and L2. So notice that here in the section view, the L1 and L2 extents have shortened when I shortened this scope box. Now we could stretch it in any view. Okay. Now what I'm going to do is I'm going to undo those last 2 modifications to get it to go back to the original size. I don't really want to change the size of the scope box, but what I do want to do is take these 2 levels and I want to associate them to the same scope box so that we're controlling those the same way. And to do that, we just simply come over here to the scope box drop down here on extents. We choose grids and levels, which is the name of this scope box. And now they will share the same extents as the original 2. Okay. Now, the next thing I want to do is zoom in just a little bit here. And I want to make one more level, but this one I'm going to make as a copy from the existing level. Okay. So I'm just going to select level 1, go to the copy tool right here, click any start point, start moving the mouse straight down. And if you're working in the imperial file, type 5 and press enter. If you're working in the metric file, type 1500, 1500 millimeters, and then you can click the modify tool to cancel out. That creates L5. I'm going to click on it, click right on the name, and I'm going to rename that to top of footing. So again, remember these are datum elements, and while they are really handy to establish the locations of floor plans, they also can be used for anything, any kind of geometry that you want to associate to a particular height. So top of footing in this case won't have a floor plan, but it will establish the locations of those footing elements. So that's just another way that you can use levels, and we'll see that as we progress through the course. The last thing that I want to do is adjust the heights of these other levels here. So I'm going to start with L2, click on it, click right on the number this time. So not the name, but the number. And in the imperial file, I'm going to type in 10. If you're working in metric, it's 3000. Then I'm going to select low roof and click right on the number. In the imperial file, I want this to be 12 foot 8 inches. Now there's 2 ways you can write that. 12 foot symbol 8 or 12 space 8. Either way, the first number is feet, the second number is inches. When you press enter, that will move that level down to that location. If you're working in metric, you want to put in 3,800 millimeters. Now, notice that the levels are overlapping one another now, making it a little bit difficult to see. Notice that there are these other little symbols here. So there's one right between the two pieces of text called add elbow. If you're having any difficulty finding that, just use your tab key. Each time you tab, it will highlight a different piece of the annotation there. And you want to make sure you're highlighting that little zigzag symbol. When you click it, it will create a little elbow in the level. Then you've got these little grip controls. You can drag those. And notice that that only affects the symbol. It does not affect the location of the level itself. That level is still at 12'8" or 3,800 millimeters. And for the final height, we're going to click in here. It's 20 feet in imperial or 6,000 millimeters in metric. And your final heights should look something like this in the imperial file. Or if you're working in the metric file, it should look like this.
In this video, we're going to lay out some grid elements. Grids are vertical datum elements that are used to locate other geometry. The most common uses for them is to locate structural geometry like columns and beams and so on. So it's not required that your project use grids, but they certainly can be helpful if you're going to have those kinds of structural elements. It's a great way to organize those elements. Now, I'm going to work here in this floor plan, and to help us get started, I've created some basic walls here to kind of represent the footprint of the building that we're after. Now, I did this just for convenience. It's not required that you have walls to start before you create the grids, but I just thought it would give us a little bit more focus while we're working here. So I do recommend that you continue in my exercise file rather than trying to use your own version for that reason. Now, I'm going to zoom in just a little bit here so that we can get a better look at that building area. And then let's go ahead and get started creating our grids. So I'm going to come over here to the datum panel on the architecture tab and click the grid tool. And the first one I'm going to create kind of randomly. So I'm going to start down here beneath the building and then pull it up at an angle like so. And then I'll come over here and click the modify tool to cancel out. And the first thing I want to talk about is the naming of the grids. So notice that they do name automatically, and this one just named as grid 1. Now that seems like a perfectly logical name, makes perfect sense, but I just wanted to point that out. Now, I'm going to delete grid 1 because I don't really want it at an angle after all. And what I'm going to do is create a new one starting at the same basic location, but I want to pull it straight up this time, running vertically. Notice it's very easy to snap to a vertical, and click again. And here's what I wanted you to see about the naming. Notice that even though we've deleted grid 1, it doesn't reset the numbering. So Revit remembers that we last left off with grid 1, so that means that the next number in sequence ought to be grid 2. So I just wanted you to pay attention to that, because if you don't, you could end up having to do quite a bit of renumbering. Now, it turns out you don't even need to exit the command to change that value. You can just simply put your cursor over that number 2. It'll say edit parameter. Click right on it to make it editable text. And then you could type in another number or even a letter. So I'm going to type in capital A, press enter. And now I've effectively renamed that grid. Then I'm going to come down here and create a new grid that lines up laterally with grid A, pull that one straight up until it lines up laterally again at the top. And notice that that new one is now grid B. So this is why it's important to pay attention to what that name is at the start, because you can save yourself a lot of extra rework of having to rename them later. Now, I'm going to start kind of midway through the building here and pull it straight up until it snaps to A and B. And then I'll continue to create 2 more running across the horizontal direction of the building. Now, I'm going to go in the opposite direction now, starting down here at the bottom of the building and creating a grid that runs horizontally in that little wing down there at the bottom. And notice that this one comes in as grid F. And that's simply because it picks up where we left off at grid E here, and it keeps going. So I'm going to click right on F, change the name, put in whatever you like, including grid 1. So grid 1 is an option for me because I deleted the previous grid 1. So if grid 1 still existed, it wouldn't allow me to use that name. So for example, if I tried to rename 1 to capital A, that will generate a warning here which says that I need to add a unique name. Okay, so I'm going to cancel that and leave this as grid 1. So grid 2, I'm going to line up at both ends. Grid 3, I'm going to go the full length of the building here and line it up only on the left. And then grid 4, I'll do it up near the top, lined up on the left only as well. So that's all the grids I need. I'll click the Modify tool to cancel out. And now what I'd like to do is show you that these grid elements, even though I drew them in floor plan, they will show in other views. So if you watched the video on levels, grids are very similar to levels. They are datum elements. And the difference is where levels run horizontally through the building, grids run vertically. So if we zoom out just a touch here and kind of look at what we've got, down here at the bottom, I've got an elevation south, and it is looking up at the building this way. Over here, I have elevation east looking at the building off to the left. If I open either one of those elevations, I'm going to see some of the grids. So let me start by opening up the south elevation. You can double click the little triangle on that symbol to open it up. As an alternative, you could come over here to the project browser, expand elevations, building elevation, and then double click South Architectural to open that up. It's up to you which method you choose. Now, when I zoom in here, notice I'm only seeing the lettered grids. Okay, so that's because in order for a grid to display in a view, it must be perpendicular to the viewing plane. Okay, so let's do that again by going back to the level 1 architecture tab here, double click the east elevation or double click it here on browser, whichever one, and notice that we're only seeing the numbered grids here. And so going back to the floor plan, we can see why the numbered ones are perpendicular to the viewing plane of the east elevation, where the lettered ones are perpendicular to the viewing plane of the south elevation. So what this means is if you draw a grid that isn't perpendicular to either of those viewing planes, so in this case, grid 5 will not appear in either the south or the east elevation. In fact, the only way that you could get grid 5 to show in any elevation or section would be to create an elevation or section that was perpendicular to this grid. So that's just the rules of behavior for grid elements. So that is a potential limitation that you need to be aware of if you're creating grids and they're at non-perpendicular angles. They will not appear in certain elevations, and you'll need to be aware of that. Now, in this case, I don't need the grid 5, so I'm simply going to delete it. Now, as far as manipulating some of these grids, we've got a lot of the same controls and grip handles that we had when we worked with levels. So if you watch the video on levels, then some of this will be familiar. So what I'm going to do is start with grid 1 here, and notice that it is snapped to all the other numbered grids on the left-hand side and grid 2 on the right-hand side. So if I were to drag this little open circle, you can see that it affects both 1 and 2. If I do this one instead, you can see it affects all of the numbered grids together. Okay. The bubbles can be turned on either side. So I can check the box here to turn it on this side, turn it off on that side, and go back again by reversing that. So again, it's up to you what your preferences are. If you've got a lot of clutter in a tight area, you can add an elbow to adjust the position of the bubbles so that they don't overlap one another. If you want to remove that bubble, just simply drag this back to parallel and it will remove that. So those are some of the controls that we have available to us. Now, in this case, I left these unsnap to one another. You can easily snap them together by dragging it over. It will lock, and now these would stretch together. So just some of the things that you can do to customize the configuration of those grids. So grids are not required for a project, but most commercial buildings will have grids. If you anticipate having a column layout, then you're probably going to want to use grids. And so as you can see, laying them out is a pretty straightforward affair. Just keep in mind some of those potential gotchas with viewing them in different views and with the way that they are named automatically. In this video, I want to discuss a really important concept in Revit, and that is one that I like to term either progressive refinement or sketch then modify. Now, these are both my descriptions for this concept, but the concept is really quite simple. In Revit, what you typically want to do when you're facing a layout task is you want to quickly and roughly lay out the geometry first, and then come back and slowly and progressively refine it into its more correct configuration. So you can think of that as you start with a really rough idea and then you progressively refine it, or you start with a really simple rough sketch and then you modify that sketch. So either way, with either description, and those are both my descriptions, they're not official Revit terminology by any stretch, but if you think of either of those two concepts, they're really describing the same thing, is that in Revit, the idea is we're not required to know all of the precise dimensions and locations of every element before we place them. We can start with whatever we do know, and then as more information becomes available to the design team, we slowly and surely massage and refine and change and transform the design to meet the newer requirements. So I want to demonstrate that process here, and I'm going to use a really simple example. I'm going to focus on these column grids that we have here. Now, if you watched the previous video where we placed those column grids, it might have surprised you that I was just sort of placing them randomly without really thinking too much about where they were. I didn't use any dimensions at all, any numbers at all. Well, that was intentional because, again, I was just sort of roughing out my idea that I needed grids in these approximate locations. And now what I'm going to do is come back and refine those positions. I'm going to take that sketch and modify it. Okay, I'm going to progressively refine that layout. So we're going to do that with a feature called temporary dimensions. Now, let me zoom in here a little bit so that we can kind of focus on the layout that we have here. And what temporary dimensions are is an on-screen control mechanism that allows you to select an element and then move its position using on-screen dimensions. So let me demonstrate by selecting grid A here. When I select grid A, you'll notice dimension string appears down near the bottom of the screen. It's called a temporary dimension because if I were to deselect grid A, which I will do by clicking an empty space, that dimension disappears. Therefore, it's temporary. So let's go ahead and reselect grid A again to bring that dimension back again. Now, it turns out there's actually two values there. There's a dimension measuring over to the wall on the left and another one to the wall on the right. And you could manipulate either value. Now, in my case, I know the value that I want for the dimension on the left. So that's the one that I'm going to modify, but you could modify either one. Revit doesn't care. Now, how do you make sure you're selecting the right value? It's kind of difficult to read down there. Well, move your mouse over the value itself. And before you click, notice that there's a box that surrounds that value. That's how you can tell which dimension you're editing in tight quarters here. So because there's two numbers and I want to just make sure I'm getting the right thing, I'm going to pay attention first to that box before I click. So when the box is highlighting the dimension on the left, I will click and that activates that value. And now I can type in the desired value instead. So what I want is for this grid line to be 4 inches or 100 millimeters off the inside face of the wall. Now, to get me to the correct location, I'm just simply going to do the math. The dimension is going to the center line of the wall at the moment. So I need to take half of the thickness of the wall and then add to it the additional value of 4 inches or 100 millimeters. So if you're working in the imperial file, we want a value of 10 inches. Now you can do that by putting in 10 and then the inch symbol, which is the double quote mark on your keyboard. If you're working in metric, use a value of 250 millimeters and then press enter. And when you do, notice that that will move grid A over to that new location that matches the dimension value that you asked for. If you click anywhere to deselect, the dimension disappears. So the temporary dimension was simply a means to an end. It allowed you to move that element. So let's repeat that with grid 1 now. So I'm going to select it. You can again see the two dimension values, and I want to use the same value again, but this time I want to edit the lower dimension instead of the upper one. So pay attention to which one's highlighting, click to select it. In Imperial, there's an alternative to using the double quote mark. You can instead do 0 space 10. So that's 0 feet and then 10 inches. It's the same thing. So 10-inch symbol, 0 space 10, it's going to get you the same place. And of course, in metric, continue with the value of 250. Okay, so those are the first two. Let me repeat with this one right here. And you can see it's quite a jumbled mess here. Now, you might be tempted to zoom in, but notice that when you zoom in, the dimensions don't really change, right? The size of everything is still the same. So that can be a little bit frustrating. So you really want to rely on that box that I was indicating to you. And in this case, I want the upper box. And that's how I can ensure that I'm selecting the correct one, 0 space 10 or 10 inches, 250 if you're working in metric. Okay, now I'm going to select this one here. And the dimension appears across the bottom of my screen there. And it's very clear now, because I'm zoomed in a little closer, that the witness line is in the center of the wall. Okay, but it turns out we can actually relocate that. So notice these little dots that appear on the witness lines. And if I put my mouse there, there's actually a tooltip that says move witness line. If you simply click the dot, that witness line will jump to a new location. It went to the inside face in this case. If I click it again, it goes to the outside face. One more time, it's back to center. And then one more time, I'm back to inside face. So just click it as many times as you need to get to the location you want. For me, that's the inside face. And now that means that instead of doing the math, I can just simply type in the distance I want, which in the imperial file is 4 inches. And in the metric file is 100 millimeters. Okay, so that's just an alternative way to achieve that. Okay. Now, let's say that you wanted to make that your default, okay? So rather than clicking the witness line grips, you wanted to make that setting permanent. You can go to the Manage tab, go to the Additional Settings dropdown, come down here to this Annotations flyout menu, and then slide over here to Temporary Dimensions. Here in Temporary Dimensions, you can see that there are 4 choices for the behavior of the wall's temporary dimensions. My personal preference is faces, but you're welcome to choose another option if you like. When I click OK there, notice that now if I select one of these grid lines, and let's just zoom in a little here to make sure that that's clear, notice it's referencing this wall up here and this wall down here, but importantly, look where the witness line grips are now. They are now at the faces of the wall. I can select this dimension and I can put in 4 inches or 100 millimeters and move the location of grid C. So the last one that I have to move is grid 3 here. I'm not even going to zoom in for that. And you'll now see that one move to its correct location. Now there's one more that I want to move, and that's grid D. And when I select it, you'll notice that grid D is referencing the walls on left and right, but maybe I don't know either of those values. Maybe I actually know the distance off of grid C instead. Well, clicking the witness line grip, that trick I showed you before, is only going to go to the wall locations. It's not going to consider other geometry. So what you do instead is click and hold down that little dot, and now you can drag this anywhere that you like. And notice you're able to highlight grids, other walls, okay? And in this case, I'm going to highlight and then let go on grid C. Now I can activate this dimension and put in the value I want, which in the imperial file is 31 foot 8 inches. And if you're working in the metric file, it's 9,500 millimeters. Feel free to continue experimenting further in this file if you like, moving not only the grids, but you can also try manipulating some of the walls using temporary dimensions. Feel free to practice and experiment and explore. The temporary dimensions mechanism is a really important part of the Revit software, and the quicker that you get comfortable with that, the more beneficial that will become to you. In this video, we're going to take a look at columns. Now, Revit has 2 kinds of columns. There are structural columns and architectural columns, both available on this little drop-down menu here. I'm going to start with the architectural columns. Now, it's defaulting to this round-shaped column, and I would actually prefer something rectangular. So if you go over to the Properties palette and click the Type selector at the top, you can see that there is another family loaded into this file called Rectangular Column. Choose the largest size, which in the Imperial file is 24 inches square, and in the metric file, it's 610 millimeters square. Now, the way that this works is you can actually place these columns anywhere that you like. So I could just sort of place it there in free space. But if you look over here on the properties palette, there's this moves with grids feature and it's checked on by default. Now we want to leave that checked on. And the way that that works is if you snap to a grid intersection instead, that grid intersection will now have control over the location of the column. So let me demonstrate. Let's click the modify tool to cancel out of the command. I'm going to select grid 3 and I'm just going to drag that a little bit. Then I'll select grid B and I'll drag it a little bit. And notice that in both cases, the dragging of the column grids affected the location of the associated columns as well. Notice that this column was unaffected by the change because we did not snap it to the grids. So that's the difference in behavior depending on whether you snap to grids or not. So what I'm going to do is undo most of those changes. So I'm going to click the drop down here on the undo command and go back to the second column option. I'm going to leave change type alone because I want to start placing architectural columns a second time. And I want to make sure that I'm still using the rectangular column. So if you undid too far, just choose the rectangular column over again. Now this time I'm going to click the intersection at grids A and 4 and then zoom in a little so we can see more clearly what that did. Notice that the column not only associated with grid A4 as we would expect, but it also merged into the surrounding wall geometry. Now that's pretty nice even at this early schematic stage, but it's going to become even more powerful later on. Let me show you an illustration of how we're going to benefit from that in the future. So later, as the project progresses and we add more detail to the exterior walls and so on, the fact that we have this embedded column in here, notice that it's going to continue to embed in those walls and even take on the surrounding materials of those wall assemblies. So that's a really powerful benefit of this merge feature that we're getting really for free. All you need to do is just click near a wall and it will automatically take on that behavior. So that's just something that architectural columns do on their own. Okay, so let me zoom all the way out. And now that we know what we're going for here, I'm going to click on each of the grid intersections around the perimeter of the building. Now, don't do the ones in the middle. We're going to do something different there. So let's just click the modify tool to cancel out of the command. And now we're going to move on to structural columns. So the structural column tool should default to a steel shape, which will have the I shape to it. I'm going to accept that default column. If you want to change to a different type, you can, but I think I'm just going to stick with this standard I shape here. Now, many of the features of the structural columns are the same as the architectural. So we can place them freestanding anywhere in space. We could place them at a grid intersection. We've got the moves with grids feature, which would behave the same way. So all of those things I'm going to leave alone, and we could do the same as we did with the architectural. The only change I want to make is here on the options bar. Notice that there are two different ways that you can establish the height of this column. So it will default to the depth choice, but there's also a height choice. Now, if you leave it set to depth, what will happen is the column will actually go down from the level. It'll disappear from view, and that'll generate a warning. Okay. So if you want to avoid that, change it to height. And then you can even further establish the height either numerically right here, or you can use this drop down here and associate the height with one of your levels. So I'm going to choose level 2 in this case so that my columns will all start at level 1 and go up to level 2. The benefit of that is later, if we move the height of level 2, it will automatically adjust the height of all those associated columns. Now, as we did before, I could just click at a grid intersection and start placing these columns, but there's a much faster way with structural columns. Notice over here that we have two different multiple placement options, at grids and at columns. Let's start with at columns. I'll click the button, and the way that this works is you want to just click somewhere in empty space and drag a box from left to right that surrounds all of the architectural columns. Notice it's only highlighting the architectural columns, and when you let go on that selection window, it will ghost in a piece of steel in each of those locations. Assuming you're satisfied with that, you can click this finish button right here, and that will complete the change and very quickly add all of those columns. So I wish that the architectural columns had a similar piece of functionality because that's a much faster way to add these columns. Now, in addition to that, we can also add them at grid intersections. So let's choose the at grids option next. Typically, this works best with a crossing selection. So we're going to go right to left this time. So I'm going to start in this empty space right here, click and drag to the left until I've highlighted the 4 internal grids only. I'll let go, and it will ghost in a piece of steel in each of those locations. Now, even though there's 4 intersections there, it's only going to create 3 new columns because it's smart enough to figure out that we already had a column at grid 3.7 and C. So it won't double up and make a second column there. Let's click Finish. And we can click the Modify tool to complete the command. And then I can sort of prove that to you by making a window selection around just the piece of steel. And notice it says structural columns 1. So there's only 1 structural column in that location. Now, if you're seeing 2, it just means you made a bigger selection and it'll say multiple categories here. So make sure you're just windowing the steel to see that it's only 1. Okay, last thing I want to show you is the structural columns are directional, okay? Because they have the I shape and the flange and so forth, it matters which way they point. Well, there's a real easy way to reorient the columns. So I'm going to select the 2 here on the left and then simply tap my spacebar. When you do that, it will rotate the columns 90 degrees. So each time you tap the spacebar, it'll rotate an additional 90 degrees. Now, I'm doing it here with columns, but that feature works with all sorts of geometry. You can use the spacebar on columns, on windows, on doors, on furniture, on equipment, even walls. And it will either rotate in 90-degree increments or it will flip, kind of like a mirror command, the geometry in question. So I encourage you to try the spacebar in other scenarios as well. Just kind of keep that in mind, make a mental note to remember to do that. So that is placing columns, both structural and architectural. If you want to experiment further in this file, I welcome you to do so. In this video, I want to talk about an alternative way to execute your commands, and that's using the keyboard. So up until now, you've seen me click buttons on the ribbon to run various commands, and that's a perfectly valid way to work. But alternatively, many of the commands have keyboard shortcuts, and a lot of folks prefer to use their keyboard to execute the commands because it can often increase productivity. So as an example, many of the commands that we've already talked about have keyboard shortcuts, like the wall command. So if I want to run the wall command, I can type the letters WA, and then I'm drawing some walls. Or previously we did grids. So I could type GR, and that is the grid command, and I can create a grid. Now, previously we did the level command. The keyboard shortcut for that is LL, but when I try to type LL, nothing happens. And that's because I'm in a mode that doesn't allow me to draw levels. So just because you're running the keyboard shortcut doesn't necessarily mean you can run the command. And a clue is right here on the ribbon. Notice that the level command is grayed out. Okay, so it stands to reason that that wouldn't work. So all we're doing with the keyboard shortcuts is getting an alternative way to run the command. Now, how do I know what these commands are? For example, how do I know that the door command is DR and that the window command is WN? Well, I didn't have some big comprehensive list that I sat down and memorized. All I did was took advantage of the tooltips that appear on the ribbon. So if you hover over a command, you'll get a small tooltip. After a moment, it will expand to a slightly larger tooltip, which usually includes some sort of an illustration or sometimes an animation. But notice that next to the name of the command, in parentheses, it has 2 letters. That's the keyboard shortcut. So if I slide over to door, notice it's DR. And then window, WN, component is CM, column is CL. Now, when I get to commands like the roof by footprint or ceiling or floor, notice that they don't have anything there in parentheses. So what that's telling me is that there is no shortcut assigned to those commands by default. But if you want, you could add your own. So if you don't like one of the existing shortcuts, or if you want to add one to a command that doesn't have one, keyboard shortcuts can be customized. So go to the View tab, click the User Interface dropdown. Keyboard Shortcuts is at the bottom of the menu here. And interestingly enough, if you look at its tooltip, it has its own keyboard shortcut, KS. So I could simply execute the command or type those letters, and I'm in this dialog here. Now, you can use this dialog to familiarize yourself with the keyboard shortcuts. Just kind of scroll through the list and you'll start to see the commands that have them. You can see there's a whole bunch of them right here that have keyboard shortcuts. So that's one way that you could use this. You could export the entire list to a text file and then format that nicely, print it out, and create yourself a little cheat sheet if you wanted to. I prefer to use the tooltips, as I said, but that is another option. And you can also use this dialog to customize the existing shortcuts. So there's an assign and remove button. So if I didn't want the scale command to be RE, I could remove it. If I wanted to add something to trim and extend multiple elements, I could type in the shortcut that I want here. The only thing you want to be careful about is not using the same shortcut more than once. So notice that AR is being used here. If I try and assign it to this one, it will warn me that it's currently in use. Now, it does say that duplicates are allowed, but I'm not really a fan of doing that. So personally, I think you should cancel there and try and find one that's not being used. But I'm not going to change anything. I'll just simply cancel there. But if you want to explore customizing your shortcuts, that is certainly something you can do. Now, some of the shortcuts use the Windows standard, and these are typically file management commands and other commands that are common across the Windows platform. Things like new, open, save, print, undo, redo, cut, copy, paste. They have the standard control key shortcuts. So control C for copy, control V for paste, control P for print, control S for save. Now, when you hover over one of those commands, it will tell you that in the parentheses. So you're still going to get the same information from a tooltip. It's just going to use the control shortcut instead of the two letters. Now, let me just make one other comment about the shortcuts, the Revit ones that use two letters. It's pretty important that you just type the two letters. Don't press the enter key. Sometimes there's an instinct to follow the two letters with the enter key. And if you do that in Revit, you're going to get unexpected results. For example, let's say I was trying to draw a wall. So I type WA, but then I press enter. And suddenly the keyboard shortcuts command appears. And I may be wondering what just happened. Okay. Well, the issue is that pressing the enter key actually repeats the previous command. So if I right click here on screen, we can see that another way. Repeat keyboard shortcuts is at the top of the list. So my last command is listed there as something that's repeatable. So let's say I did do WA and I'll draw a wall. I'll escape out of there. Right click. Now the last command is the wall command. So if I do DR and press enter, I thought I was going to be drawing a door, but in fact, what I'm really doing is drawing a wall now because it ran the door command and then immediately canceled it and repeated the last command, which was wall. So something to be aware of. If you're in the habit of pressing enter after a shortcut, you really just need to work hard to break that habit. It's a muscle memory kind of thing. So if you're committed to using keyboard shortcuts, that's going to be something you're definitely going to want to get control over because otherwise you're just going to be frustrated. So from this point on, I will try to point out to you when shortcuts exist, but I will continue to show you where the commands are on the ribbons as well. And you can use whatever method suits your own personal preference.